Close your eyes and picture your earliest ancestor. Not a caveman cartoon, not a museum diorama, an actual person, standing under a brutal African sun about 200,000 years ago, squinting at the horizon and worrying about the same three things every human worries about: food, safety, and whatever that rustling noise in the grass just was. Skin color was the last thing on their mind. It's the first thing on ours. And that gap between what mattered to them and what matters to us is basically the whole story. Here's the question that trips people up. If every human being alive today descends from that same small population, why do we look so different now? Why does a Norwegian grandmother have almost translucent skin while a farmer in Ghana has skin dark enough to shrug off equatorial sun without sunscreen? The honest answer is that we didn't start out different at all. We started out the same, and the differences came later, much later, and for reasons that have nothing to do with beauty, superiority, or anything a person chose. Scientists studying ancient DNA are fairly confident about one thing. The first Homo sapiens had dark skin. Not brownish, not olive-tone dark, dense with melanin, built for a place where the sun doesn't take days off. Melanin isn't decoration. It's biological armor, absorbing ultraviolet radiation before that radiation can shred folate in the bloodstream or mutate skin cells into something dangerous. In a place like equatorial Africa, where UV exposure is relentless year-round, that armor wasn't optional. It was the difference between a body that worked and a body that slowly broke down. Evolution, to be clear, was never rooting for any particular look. It doesn't have taste. It has one blunt metric: did you live long enough to pass your genes forward? Dark skin passed that test for hundreds of thousands of years. So dark skin became the baseline for our entire species. There was no white, no Asian, no category anyone would recognize today. There was just humanity, living in Africa, looking roughly like each other. Then people started leaving. Somewhere between 60 and 80,000 years ago, small groups began drifting out of Africa into the Middle East, up into Europe, east across Asia, eventually all the way into Australia, and, absurdly, across a frozen land bridge into the Americas. No maps, no idea what was on the other side of the next mountain range. Just movement, generation after generation, chasing food and space. As those groups pushed farther from the equator, something quietly shifted beneath their feet. The sunlight itself got weaker. Less UV radiation sounds like an obvious win, less cell damage, less risk. Except the body doesn't just fear the sun, it also depends on it. Sunlight triggers vitamin D production, and vitamin D isn't a luxury. Weak bones, fragile immune systems, developmental problems, all of that follows a population that can't make enough of it. Suddenly, the thick melanin that had been a lifesaver in Africa was blocking sunlight a body in Scandinavia or Siberia genuinely needed. Natural selection noticed, the way it always does, over thousands of grinding generations rather than any single lifetime, and slowly began favoring lighter skin in places where the sun simply wasn't strong enough to punish it. What surprises most people is how late typical European skin actually shows up in the fossil and genetic record. Early hunter-gatherers who lived in Europe thousands of years after the first migrations still carried dark skin, in some documented cases paired with blue eyes. A combination that reads like a genetic mismatch, but is exactly what the ancient DNA suggests actually existed. Pale skin, as the regional norm, arrived far later, tangled up with the spread of farming, shifts in diet, and repeated waves of population mixing that pushed certain gene variants to become common. None of it happened because lighter skin was an upgrade. It happened because, in that specific environment, it worked better for making enough vitamin D to keep a population healthy across generations. Meanwhile, populations moving east into Asia ran into a nearly identical problem: reduced sunlight. The same vitamin D pressure, and arrived at a similar answer through a completely different genetic route. Two students can land on the correct answer using entirely different methods, and that's roughly what happened here. European and East Asian populations both evolved lighter skin than their African ancestors, but many of the specific mutations responsible are distinct. Evolution wasn't running one master script and copy-pasting it across continents. It was solving the same environmental puzzle over and over, independently, with whatever genetic material happened to be available in each population. That's not a minor detail, it's one of the clearest signs that human variation isn't a single family tree branching outward in an orderly way. It's dozens of separate experiments running in parallel. Most casual conversations about race collapse skin color into three tidy categories: dark, light, and in between, as if humanity sorted itself into a paint sample chart. It didn't. North Africans and West Africans developed different pigmentation patterns from one another. South Asians and East Asians diverged along their own paths. Indigenous Australians, isolated for tens of thousands of years, followed a trajectory almost nobody else shares. Native Americans carried traits inherited from ancestors who crossed through Asia long before anyone was writing anything down. Add it all together, and you don't get three categories, you get a continuum stretching across the entire planet, shaped by thousands of years of sunlight, geography, diet, and interbreeding between neighboring groups. Trace any two people on Earth back far enough, regardless of how different they look standing next to each other, and their ancestry eventually converges on the same African population. Every branch, no matter how far it's traveled, connects back to the same trunk. That fact tends to make people uncomfortable in a strange way, mostly because it collapses a distinction that feels enormous in daily life into something almost trivial on an evolutionary timescale. The visible traits we spend so much energy sorting people by skin tone chief among them represent a genuinely tiny sliver of our species' history. Underneath all of it, humans remain startlingly similar at the genetic level, more similar than most people would guess if you asked them cold. Which brings the story back to that person standing in East Africa 200,000 years ago, with no concept of Europe, no concept of Asia, no way of imagining satellites or smartphones or arguments happening in comment sections between strangers who will never meet. They were just trying to make it to tomorrow. And somehow, inside that one ordinary person and the small population around them, existed the raw genetic material for every skin tone that would ever exist, every shade, every population, every face staring back from a mirror right now. So no, humans didn't start out looking like the world looks today. We started out looking like each other, painted in one shade by one relentless sun. Everything else, every variation, every shade, every so-called category is just sunlight, migration, and time, quietly doing what they've always done.